Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask an Engineer. It's me, Lady Ada, the engineer. With me, Mr. Lady Ada on camera control, typing stuff in, posting links and codes and stuff. We got like a jam-packed show, lots of new products this week. Maybe not as many videos, but a lot of top secret coming soon. In fact, we had to take two things out because it was too much. Mr. Lady Ada said, "Nah, too much top secret. We gotta like bring it down a little bit." So maybe next week we'll have two more from this week. But let's get started. What's the code and what's on tonight's show?
All right, on tonight's show, the code is SENQT. You'll see why during our new products section. Talk about our live shows. Show GP's product pick of the week. We got some main New York City factory footage. We got a 3D printing speed up. We got Ion and PI. This week is Ames Ashram by Adafruit DigiKey. We'll talk about that and more. Top secret, we got a bunch. New products. You can answer your questions. We do that on Discord, adafruit.it/discord, discord.gg/adafruit, or you can post your questions throughout the night in the chat. We get to all of them, all that and more on, you guessed it.
Okay.
Alrighty, so don't forget, code is SINQT. Lady Ada to get free stuff. What do they get?
That's right. When you order from adafruit.com, support our distributors, but also when you order direct, you get free stuff because we can give you free stuff. $99 or more, you get this beautiful black PCB coaster with a gold design on top of it and some bumpers to keep your hot or cold drinks off your desk. 149 or more, we're giving away still the KB2040 all-in-one RP2040 based microcontroller, which is Pro Micro Pinout compatible, has a stubby QT port, buttons, NeoPixel, flash memory, USB-C, and some castellated pads. It's good starting micro. Free shipping for orders $199 or more and $299 or more. We're still giving away Circuit Playground Expresses. It's round. It runs Arduino or Code.org, CS Discoveries or MicroPython or CircuitPython or Rust. Make code. It's awesome. It's a great way to get started with electronics. No soldering required. Just plug it into micro USB and you can get started with all that cool stuff built in.
Okay, we do a bunch of live shows. Show and tell was just a few moments ago. Thanks so much, Liz, for hosting. And don't forget, if you're going to be on show and tell, you can also put your projects on Playgrounds. We'll talk about that later on in the show. It's part of learn.adafruit.com. Check that out. We skipped Desk of Lady Ada over the weekend, but we will be back. So tune in.
Tune in next weekend, yeah.
The latest Desk of Lady Ada and Great Search. On Tuesdays, we do JP's product pick of the week. Here is this week's highlight.
The Pico DVI sock and the Pico DVI Pi cowbell. Plug this into the HDMI, and then since I have a little battery in the battery shim there, I can just turn that on. There's the little Max Headroom TV host demo that Phil Burgess did a little while ago, and that is running right off of their tiny little sort of HDMI shank, DVI shank sort of thing. Got the cowbell on a little Pico doubler side by side there. And in fact, I'm running this off of a battery, so you can see the only cables coming out of it, only singular cable coming out of that right there is the HDMI going through a little micro or a mini HDMI adapter. And if you look behind me there, we've got that Flying Toasters demo. So that's playing right there. So look. Product picks this week, it is the Pico DVI sock and the DVI Pi cowbell.
And don't forget, on Thursday, JP's workshop. On Friday, it'll be deep dive with Scott or Tim. Let's go to Python on hardware. All right, Lady Ada, this week in the newsletter.
Happy birthday.
Happy birthday, MicroPython. It's 11 years old. It's what we base CircuitPython off of.
Yeah, I mean, like this, it's amazing. I remember the first Kickstarter, and we actually helped support and promote that Kickstarter because they were like, oh, we want to use, I think the ESP8266 feather is one of the boards, and I was like, yeah, absolutely, we'll tell people like, go for it. I thought the idea was really cool, and I gave a talk a few years ago at Linux Australia. I don't remember the full title of the conference. And I talk about actually, the history of MicroPython and kind of when I first saw it. MicroPython, started again with the the STM32F405. That was like the original Pi board, and then they did. I think the ESP8266 is when it really took off. They did that Kickstarter, a couple Kickstarters to help fund development, and it's kind of been like been a machine. A lot of you guys are not even that long in development microcontroller SDK land. And then, you know what, like 6, 7 years ago, 8 years ago, is when we started using MicroPython on our boards. And then we decided, you know, we had some design changes that we wanted to do that were not compatible with what MicroPython wanted to
We
do.
needed Python on hardware that worked with a ton of different devices.
Yeah.
They were basically on one. And we're like, well, what can we do to support multiple chips, all the peripherals, all the accessories, all the sensors?
And Raspberry Pi. It's one of the things I wanted
Yeah.
to have Blinka support. And so, you know, we kind of went our separate ways. You know, we did a lot of development on CircuitPython and MicroPython. And then recently, actually, we kind of joined back up again. We've been upstreaming more code, a lot more bug fixes, talking with MicroPython, and you know, sharing design ideas as well. And we also are like one of the biggest contributors to MicroPython, which
Yeah.
is great.
So they don't exactly sell the same amount of hardware as when they first started. So
Well, it's been like a tough couple of years.
yeah, so
Couldn't get any SDM chips.
so if you want to support them, just go to micropython.org and look for the GitHub sponsors.
Yeah.
We've done a fundraising thing each year, and we donate every month, and we try to get the word out. So
And it's a great way to get them to actually hire. They hire people with that
Yeah.
money, and then they actually do more development. So they brought on more developers, and definitely the speed of merging in PRs, adding new chips has increased. So I mean, I think definitely. I remember like MicroPython felt so disruptive. It still feels really disruptive, like in a good
Yeah.
way, not like bad disruptive, but like innovative.
yeah, and you know, it's been a decade-ish of, I think, especially for educators, that's what we heard is teachers were like, we're not going to be able to do C, C++.
Yeah. I mean,
Uh,
Python is like the language
we're-
that so
we're
many
gonna-
schools are
We're going to have to,
teaching.
yeah, we're going to do Python and we want to do hardware. So this
Yeah.
was like a good combination of the two. So happy birthday, MicroPython.
Another thing I thought was kind of cool is check out this talk, yeah, on Zephyr and MicroPython, because actually Scott was telling me, you know, he, I think he was at this event maybe. So, you know, Zephyr is a real-time operating system that runs on a lot of microcontrollers. It kind of, you know, I don't want to say it's replacing Mbed, although, you know, to be honest, Mbed sort of admits that they're kind of done. But Zephyr's kind of, you know, the RTOS that supports a multitude of platforms and chips. A lot of our microcontroller boards are supported within Zephyr. And we've been actually kind of leaning towards using Zephyr more as they're starting to add more dynamic configurability to their operating system, because it would be really neat to, you know, if we use Zephyr as sort of this middleware to do all the timers and ADC and, you know, CAN bus and Wi-Fi, whatever, all that layer work, and we build a port of CircuitPython that uses Zephyr, we could, you know, add new chips and variants much, much faster. So it's definitely something that we are kind of like looking at. We've kind of chatted about it a while, but maybe making progress now that Zephyr is becoming a little bit more dynamic. That's the thing. We want to be able to, in runtime, not at compile time, define what every pin does.
Check out the CircuitPython versus Arduino C++ language for ESP32 comparative analysis. I thought this was really good. It's fair. It's like what right tool for the right
I
job.
never say that CircuitPython's going to be faster running the
Yeah.
code, but it's definitely faster developing the code.
Yeah, and they pretty much said the same thing.
Yeah.
So,
And that's okay.
and I actually think, you know, while the world is polarized and pretty much everyone hates each other, in some groups of programming, people start to chill out. They're like, "Hey, both are free. Try both."
You know, it's like these
Yeah, you're
it's
not-
so good.
Yeah, it's not like you're commercially locked into either one, and you can run usually both on.
It's like that meme.
microcontroller.
It's like chocolate cake or carrot cake. It's people
Yeah,
like both,
but it's like-
both cakes.
But it's like, yeah, and even say it's like there's nothing locking you in either one. So try both and figure it out.
Two kinds of cake.
You know, their summary was basically if you need to get stuff up and running and you want to develop fast, CircuitPython's the way to go. If eventually you need some type of optimization or performance or whatever, maybe Arduino.
Well, I mean, like that's actually kind of like if you scroll up, that's what this Zephyr talk is. It's you build it faster with MicroPython and Python on hardware. That's the point. Is you can you can get started much quicker. And I'm starting to see more chips, like when I do INPI and I kind of like look at chips and stuff.
Yeah.
More and more companies, silicon companies, are embracing Python on hardware to get people using their hardware without like this 3-month SDK like nightmare.
Yeah.
Yeah.
Anyways, more
Okay.
stuff. You can check out the newsletter, 3,000 guides. There's a lot of comparison articles. The
I just actually
PSF,
just read this PSF thing, so I was actually
yeah,
interested.
their annual impact report is out. You know what is all the good that they're doing throughout the year. It's always good to see this. Do check it out. The PSF is one of the places we support
That's right.
as well. PyCon's coming up.
And we're sending Jeff later to Hong
Jeff will be there. So check out the latest and greatest from the newsletter. Sign up. Good thing about the newsletter is it's on Adafruit Daily. You can get on GitHub, you can get it on the blog, you can get RSS, you can get an email. It's on a completely separate website sent to you. We don't spam, we don't share email address. To check it out. Okay, let's talk about some open source hardware. We have
Yes.
a bunch of new guides on the big board. We have over 3,000 guides. Lady Data,
Okay.
what are they?
This week, to be honest, well, yes, we have a couple of new guides. Liz, of course, cranking out the guides for new products. Thank you, Liz. She does it on top of also writing so much code for other people doing projects. So, everyone thank Liz. Total superhero. So she did a guide for the USB host BFF. This is a board that you can plug into your QT Py to add a USB host port, and you can connect to keyboards, or we're going to do a project with MIDI keyboards as well, not just HID like clicky clacky keyboards or mice. There's USB hub support, USB serial, so you can connect another microcontroller in. Neat stuff. I mean, this is kind of an ancient chip, but now that it has TV USB support, it works great in Arduino, and then CircuitPython support is pulled into main, but is not fully documented. But if you want to be cutting edge, you can check it out. We have the guide for last week's JP's project, the arcade stick conversion. This was like a PS2 X arcade stick, and there's off the shelf like DIY like X keys or whatever. Like you can wire up a key to each pin type products, but we thought it'd be cool to do it with no soldering and using a Raspberry Pi Pico, because then you could program it with like KMK or QMK, or I think he uses another MK tool that allows you to dynamically change and update. And the best part is that it's all open source hardware, so you don't have to worry about the product getting discontinued. You can play Street Fighter forever. And the board he's using is this like terminal block expander that was inspired by the wing shield that he co-designed. So it was a lovely like circle of life. And then also Liz did the DVI sock for Pico guide, just a little board that you fit onto the bottom foot of your Raspberry Pi Pico to add an HDMI port. That was also, if you remember, that was JP's product pick of the week.
Okay, and then if you haven't already, check out Playground, adafruit-playground.com.
Yeah.
You can check out just by clicking Playground.
There's a couple, if you want to click on features.
Yeah, features, there's always some really
There was,
good
okay,
ones.
so this one I thought was hilarious. So this guy, there's like the puppy buttons.
Yeah, they wanted to see what they said.
So this one they logged what the puppy was pressing the buttons to say. I just think it's hilarious. It's like,
Yeah.
what did my dog say yesterday?
Yeah. Mommy, daddy, later, potty walk, play water.
That sounds like dog. And so they used Adafruit IO. I thought it was pretty cool.
And we have a free tier, and I thought it was funny, as they said, is like they can't justify spending money publishing their dog's requests online, but Adafruit IO has a free tier, which we do. So do check it out.
Anyways, I love this one because it's like sometimes the silly stuff is I don't know, the most fun. I was like, oh, it's a cool idea.
Yeah, so you can see all the puppy buttons. There's fun videos where the dog is, talking, and you can. But you can check this out, and if you want to.
Yeah, and they did it all in either CircuitPython, or they did it on a Raspberry Pi, and then there's a bunch of other projects. I thought some of it was cool, like people. And
then the prop from
props and stuff.
Last week's show and tell. The week before is on there as well.
So
do check it out.
Post your projects. It's free.
Yeah, we'll feature them.
No ads.
All right, and that is open source hardware guides and
we
more.
have to check in how many registered, because Liz has been registering all of the boards.
Yeah, we have a lot. We have a lot of certified open source hardware. I think we're up to 27% of open source hardware.
It's like probably the number, I think, was it 700?
It's 780.
Okay, maybe at 800 we'll
we'll see.
Celebrate.
Actually, let's just go there now.
What?
Yeah,
live?
Yeah, we can just go there now.
Okay. That's how you know it's not pre-recorded.
No, let's go there now. let's see, certification, and then we can go to see all OSHA certified projects. So there's 2,768. Let's do Adafruit, 750.
Okay. I was
Yeah.
I guess there's like, oh, I bet it's like some kind of fun round number.
Yeah. Oh yeah, that's somebody there.
Okay, cool. 750.
Good stuff.
So 50 more than last time.
Yep. All right, and that is really it. Okay, let's look at some factory footage. And that's some glimpses on how things are made. For 3D printing this week, we have a speed up. Take it away, now Adria. Okay, and don't forget the code is SENQT. Let's do some item count.
On MPI.
Brought to you by DigiKey and Adafruit. This week it's Ashram Lady Ada. What is this week's new product introduction, Ion MPI?
Okay, yes, AMS Osram, it's a merge, and AMS used to be Taos, have a new sensor out. I thought it was pretty cool. This is a true color sensor called the TCS. Wait, let me get the exact right number. It's the TCS 3530, but on DigiKey it might be the 3532. And this is you can see the sensor in the middle. It's a fully embedded true color ambient light sensor with flicker detection. And that's what I thought was interesting. It doesn't give you RGB output, it gives you XYZ output, and it can do flicker detection up to 7 kilohertz. So this would be a sensor that you put in a monitor or a tablet or a phone or printing equipment, something where you basically want to detect color. And best of all, you want to get the color that is XYZ CIE space and not RGB space, which we'll show off in a minute. One thing that's I thought was pretty nice is that the sensor is it's not a super low cost sensor, but that's because they fully calibrate it and it's normalized. And so you're gonna get repeatable results for the sensor and also between sensors. So if you're using this chip in your product, you don't have to do another calibration step for each sensor, which you would have to do for low color. I just wanted to put Cyndi Lauper in here. True colors are beautiful. This famous song in the 80s. So I sang it the entire time I put together this Ion MPI. So we've been selling stuff from Taos AMS for a long time. And so I have a lot of experience with their sensors. So one of the first sensors we actually sold was the TSL 2561. This is a Lux light sensor with I2C. And it's a beautiful chip. And, basically they've got like decade plus of experience making light sensors and color sensors, another really popular chip that we sold or still sell. The TCS 34725 is an RGB sensor, which had interrupt output, I2C, and we wrote Arduino and CircuitPython and Python libraries for it. And this chip was great because it was one of the first sensors where as long as you had some light bouncing off the object, you could detect the color. So in this case, you put the orange on top, you illuminate it with some white light, and then you can see the RGB LED. You take the RGB color value, you normalize it, and you pipe it out to the LED, and it would get like kind of close. But RGB color space, although it is, has a full like 24 bits, 8 by 8 bits by 8 bits of red, green, blue color, it doesn't actually match what the human eye sees and how like we react to color, because we have like these red, green, blue cones, and they're like non-linear, and we have a different way of what we can see on monitors and in paint and ink, and in light. It differs from just that RGB space. So the CIE, also known as the XY color gamut, as shown here, is how most people, especially in the center where you talk about temperature of light. So like where that E is, that's kind of like, the white color. And then as it moves around, you get different temperatures of light from like 3,000 degrees incandescent up to like 6,000, 8,000 plus fluorescent or daylight. This is what like most people who do color calibration use, and not like RGB, which is again not true to what the human eye detects. So the way the sensor does it is inside there are 8 different PN diodes at the top there, XYZ, and then infrared, clear, etc. And it goes into this engine, which can multiplex between the different diodes to read each one after the other. There's the modulators for each one, and the reason you need a modulator is because if you have flickering light, because you have fluorescence or you have halogen or incandescents that are plugged into 120 hertz power, you're going to get a flickering effect. And so you want to make sure that when you read the sensor, you're not reading it during the flicker, where you're going to get much lower values. And when you're reading multiple times, you're going to read consistently at the same time. So you always get that same like normalized value, right? So if you're going to read one waveform's worth of incandescent light, you need to read like, the period of 120 hertz consistently, so you can get a full measure of light and not get like the trough or the mountain part of the reading. And so that's where the flicker detection comes in, because it'll help you determine like, oh, you're in front of a flickery fluorescent or incandescent, or a monitor, which is going to be flickering at, maybe 30 or 60 hertz as well. The sensor elements are all arrayed in this like beautiful grid. I think if I had a scanning electron microscope, which maybe you have one, this would be a really cool sensor to scrape the diffuser off and get an image of. So the diodes are laid out in a way, I've read once that the layout is actually important because you don't want like cross contamination of electrical field and light from sensor to sensor. So they're laid out in this symmetric pattern, so that when the light comes to the diffuser, you get an even amount of each element's light reading for that peak of the frequency for that particular PN diode. So if you look here, they actually have the normalized spectral response. And again, one of the nice things about these sensors is that each one is calibrated at the AMS Osram factory. So you don't have to worry about like, oh, the 750 nanometer diode is going to be much more powerful than the 600 nanometer, and so I have to divide it by a certain number for it to equal out. So they've already done that for you, which is again part of the cost included in the sensor, is that extra time that they spend to calibrate and trim it. So these are all of the diodes. So you can see it does cover like a really nice wide range from about 400, maybe 425, 450 nanometers, up to about 750 to 800 nanometers. And then this is the accuracy depending on the conditions. So you'll see you're going to get, of course, the best conditions are going to be at the 3,000-ish to 5,000 range. But at least they do document like, here's what your measurement accuracy is going to be for each color. And so maybe you can use that as part of your color tuning when you do the measurement. You're like, oh, I read it. I think it's a fluorescent 4K. Okay, I know that maybe I have to adjust it by a certain amount to match with the accuracy I think I should be expecting. Okay. One thing to note is this is a fairly simple sensor to integrate. It's only got like 8 pads on the bottom because it's basically just like power, ground, I squared C, IRQ, etc. But one thing to watch out for is it's not a 3.3 volt sensor. It's 1.8 volt maximum for the power supply and IO. So if you're going to use this with 3.3 volt microcontroller board like a Raspberry Pi or something, you're going to need a level shifter. Second, it does have I3C support, which we covered in a previous INMPI. So if you have like a modern platform that you're developing for, you know, this is, you can kind of tell this is designed for like tablets, phone, something running Android, or similar. You know, you might be able to take advantage of I3C, and then your interrupt pin, you know, can be part of like the in-band signaling, and also you get the higher speeds of I3C. For drivers, didn't look like there was anything from microcontrollers. The only driver I could find was a Linux driver, but it is fully published and it's in C. So it looked like it wasn't too bad to port over, but there are a lot of registers, like 100 registers. So definitely writing a library from scratch is going to be a challenge. I would start with the Linux driver and port it to your platform if you can't or are not able to use a kernel driver.
In stock.
That said, it is in stock right now. There's lots of them, 5,000. I ordered a couple. Might check out making a breakout board for this sensor. It's kind of cool. What is neat is that it has everything included. You don't need a lens, you don't need a diffuser. It's really like drop and go, instantaneous, and you get this pre-calibrated output. It's quite nice.
Here's a question: can the XYZ plus IR plus HG color space be converted into something like Kelvin?
I believe that they do provide algorithms to tell you what the color temperature is of the light, but usually you actually do want to have like the XY HGIR value, and you feed it into your camera driver and you tell it like, hey, I detected that this is the light levels, or to your monitor, like your monitor driver, you would tell it, hey, the ambient light is this, and so I want you to you know, change the color temperature of the pixels being written to the driver. So this is like the two main use cases. And I'm pretty sure that you usually want the extracted out values and not just give it like 6,500, you know, or 3,000 Kelvin. But yeah, I think if you have pre-calibrated XYZ values, then yes, you can absolutely convert that to temperature.
And we have a video, and then we'll get a new part. Thanks.
Sensor includes the silicon die with the photodiodes and a full optical stack with our latest XYZ filters, and even a diffuser in one package at a size of only 2.5 by 1.8 millimeters and a height of 1.5 millimeters. There is nothing fancy about the demonstration device itself. We have only added batteries, buttons, an LCD, and a microcontroller that runs our driver. The whole optical stack with the white diffuser on top is inside the little sensor package. There is only a typical cover glass placed above in the demo device, as you can see. Every single sensor is calibrated in our production test with a spectrometer and different kinds of ambient light with different color temperatures. The software driver takes this individual set of calibration values together with the actual raw data of the sensor to achieve high accuracy of the XYZ values. And it derives lux, CCD, and chromaticity using CIE standard formulas. At the same time, the sensor captures flicker data as well, and the microcontroller can find the main flicker frequency by doing a standard FFT calculation. That way, this sensor provides everything needed for camera assistance in smartphones, tablets, and laptops. The full optical stack and the individual ambient light calibration of the sensor makes the integration into customer products easy and reduces time and cost on customer side.
on MPI.
Okay, don't forget, code is SenQT. All this free stuff can be added to your cart if you're in the US, and expires around midnight. So with that being said, let's go to new products.
Okay, kicking off, we have in the store the official Raspberry Pi starter pack, which comes with case, keyboard, mouse, power supply, USB cable, as well as keyboard and USB cable, two HDMI to micro HDMI SD card, and the official Raspberry Pi beginner's guide. Raspberry Pi 5 is not included, but that's what it's designed for. If you pick up a Raspberry Pi 5, we stock them in 4 and 8 gigabytes. You add this on, basically for about $100. You've got a full working computer as well as a starter kit to get you started on how to use it.
Next up.
Next up, we found a bunch of these tricolor e-ink displays that honestly I thought that we had sold through, but we didn't. So they're in the store as a discount. If you would like a 152 by 152 tricolor e-ink display that we have drivers for in Arduino and CircuitPython, check it out. We tend to tend to use the 200 by 200 pixel ones, but the 150 by 150 pixels are also very fine quality. And I think these use the SSD 1680 driver, which is quite popular.
All right, next up.
Next up, by request, we had some folks email us and say, hey, can you make a little breakout board for STEM and QT? And I was like, well, why don't you use like a cable? And they're like, no, we want something that can like be put in a prototype. So if you're breadboarding or perf boarding and you want to add a STEM and QT port, you can, solder this in directly and you get a little port with mounting holes. And I was like, okay, get something together. It's a very simple board, but it's effective. You get your JST SH compatible connector. On one end, you can plug your Quick or STEM QT controllers or devices on the other side. It can work either way. And on LED, you can disable the LED if you like. And two 10K pull-up resistors also disableable. Just cut these traces on the back. Solder some wire or header to it, and basically a little breakout board that gets you your STEM QT port for use in your prototype.
All righty. Next up.
Okay. Another request, a lot of requests, but hey, if you email us and ask for something, there's a good chance I'll make it for you. We had some folks email and say they wanted like something that could simulate a PC fan. So it would generate 100 hertz signal that you could then plug into your computer and it would think that you had a fan. So if you're using water cooling or oil cooling, it wouldn't be like angry that you didn't have a fan connected. And I was like, oh, well, like having a general purpose PWM generator is not a bad idea. Go to our friend, the 555, and spun this together. So it's got a JST PH connector, so you can just plug and play, or you can solder wires and pins on the bottom there if you'd like. Provide it with 3 to 12 volt DC, and then you can select the range from about 15 to 250 hertz with the switches on the left, or 1.3 to 25 kilohertz if the switch is on the right. So kind of low frequency, high frequency. And then the fine frequency adjust, you twist the little potentiometer in the middle, and then you've got a nice solid square PWM output with a buffer, so you can use it to drive LEDs or even a small speaker if you wish. And then there's a signal LED to let you know, it pulses with the signal. Of course, it's at high frequencies, you're not going to see it. And an on LED. I thought I would show a quick demo. So this is it at the lower frequencies. So I twisted this all the way down, and you can actually see the this flickering. I mean, it's even to me, but of course the camera is picking it up a little funky. But it's flickering at about 14 hertz or so. And then as you twist it, it gets faster and faster and faster until it reaches about 250 hertz, which is the max. If you see on the left here, 250 is the maximum over here. If you flip the switch to the right, it changes the capacitor, and now you're up to 25 kilohertz. You can see the little K there, or you can turn all the way down to about 1.4, 1.5 kilohertz. So, kilohertz range on the right, hertz range on the left. So it could be good for, like this person wanted, simulating a PWM fan tachometer output, but also if you just need like a square wave or like, testing some audio stuff and you want like a 10 kilohertz square wave just to see like what, are you getting an audio path or something, or maybe modulating an LED? I don't know. I think like a general purpose PWM maker. Anyways, so this is a 555 timer stemma board.
Alrighty, and star tonight, besides you, Lady Ada, our team, our customers, the open source community is.
Dun, dun, dun. Okay, the SEN 54 adapter, which maybe let me get. Hold on, I gotta get rid of this demo to show the other demo. It's too many demos. Okay, so the SEN 54 is, we don't actually sell it, but DigiKey does. So go pick it up from them. And we featured it in INMPI. It's an all-in-one air quality sensor that has volatile organic compound sensing, temperature, humidity, and then PM, so particulate matter, 1, 2.5, 4, and 10. So you kind of get a range of particulate matters. And so it's, other than CO2, it has kind of everything you want to detect air quality. But one of the things about it, if you go to the overhead, is it has this connector. It's a JST GH connector. And then another thing that's a little annoying is you definitely need 5 volts. There's this little fan that sucks air in. And for it to work, you need to give it 5 volts at 100 milliamps. But a lot of folks don't necessarily have 5 volts because they're using a 3.3 volt microcontroller. Maybe they're running off a battery, or you just can't, you don't necessarily have a 5 volt power output. So this adapter board, first off, it gives you the GH connector. So you just use one of our GH to GH cables. So it's like plug and play. And then down here, this is a 5 volt booster. So even if you're powering it from 3 volts, like on this ESP 32 S3 Cutie Pie, you get a 5 volt power output, and then the I2C signals going through. So then I can reset this. You can see it's initializing sensor. Okay, and then you get the temperature, and you can kind of see the PM 2.5 signals over here. So with STEM IQT, it's plug and play. It's super easy. Now you don't have to do any wiring or soldering or connecting up a boost converter, because it's ready to go. You get not only the cable adapter, but the power adaptation as well.
Alrighty, and with that is new products. Okay, don't forget the code is SENQT. We will be doing questions shortly. You can put them in Discord. Let's do some top secret.
Yep.
All right, what's this?
Okay. I needed this for some testing. I wanted basically a USB extender doohickey that I could disconnect the 5 volt or the data lines, and I could kind of select which lines were connected, so I could do like some power monitoring, data monitoring. So this just has USB-C, Type A port, and then these 100 milliamp switches in the middle, and you can just flick them back and forth to select which ones are connected.
All right, what's this?
This is another request. So I guess, Semtech, which they're famous for their LoRa chips, they came up with, a couple of years ago, they came up with the SX 1262, which is a longer range, better power management LoRa chipset that hopefully uses a similar underlying SPI protocol driver. So it has very, very similar, but not quite exactly same footprint as the SX 1272 or 76 series. So I made a quick breakout for it and like adjusted the board we had.
Okay, what's this?
This is by request. Carter really wanted me to update the soil sensor because it's not bad, but like it's using the capacitive peripheral on the SAMD09 it wasn't linear, and it was a little annoying. So this is a version that uses capacitive sensing, but doesn't manually. It doesn't use a peripheral. It literally just like excites a 1 mega ohms RC filter and just sees what the delay is to measure the capacitance. Also has like, two, the power, it basically creates a capacitor with the, ground and sensor input. And then uses stemma QT now instead of stemma, so you can chain it. So you have multiple soil sensors, and then address selection. And they decided to make a trinky version, so it's kind of an all-in-one variety. It's got like the stemma QT layout, and then it's got this soil sensor part, and it's a SAMD 21, and then I also tossed a light sensor, a NeoPixel, and an AHT 20 on there, so you could have like light, temperature, humidity, and soil moisture. It's just kind of an all-in-one like little plant friend. We need a good name for this one. Another request. Well, actually, not a request. We see a lot of people searching our site for the HX711, and I'm like, oh yeah, like it's a kind of a popular SPI-ish Wheatstone bridge slash strain gauge, sensor. So I decided to make a quick breakout similar to our NAU 7802.
And let's stop.
And last up, this is like a funky chip. I was looking for something else and bumped into this chip from WCH. So it's a UART to HID keyboard. So it pretends to be a keyboard, and like whatever ASCII values you send over the RX over the RX pin get converted into the character that's typed, I think. Anyways, we'll try it out. I have no idea. I'm assuming it works.
Alright.
But like for ESP32s, where you don't have native USB, you can like have a HID keyboard.
That's top secret.
Okay, let's get some.
Yeah,
Okay.
we're gonna see if there's any questions this week.
Also fine if there aren't any.
If there aren't, that's totally okay. You can hang out in the chat afterwards. People hang out and help each other there. All right. Can you control a NeoPixel without a microcontroller in it?
It's hard. You have to generate that timing, and so you need to have some real-time chip to do it. You don't necessarily need a microcontroller like the FT232H can control NeoPixels through USB through a computer, but like by abusing the SPI data pin.
Okay. For the low power timer wake up introduced last week, will there be an Arduino library?
Yes, there actually is an Arduino library. And Liz is, I think, adding it to the library manager. If you search on GitHub, I believe the library is there because I wrote some example code. Yeah. It's just not in the library manager yet.
Okie dokie. Let's see. Some folks are going to pick up the Sensorion sensor.
Yeah.
Todd is going to make this synth with all these chips.
Yeah.
I think that might be it. I see someone typing. I'm going to just wait a couple more seconds.
Type faster.
So downside of knowing when someone's typing.
I know.
So, like, should you wait, or is it a cat on a keyboard? Just like, yeah, see, now it's gone.
I loved Y text because you would see what they were typing and it felt so much more like a human time.
Okay, here it is. Ready?
Yeah.
I know you've mentioned PCB layout software before, but is EagleCAD Fusion 360 going away?
Eagle is going away. I believe that the circuit layout and schematic capture is being integrated directly into Fusion 360. Is called like Fusion 360 Electronics. I don't really know anything other than that, but like 2026 is when I have to make a call whether to try this Fusion 360 or go to KiCad.
Yeah. All right. So that's really it.
Future me will deal with that.
Them's our questions.
All right. Bye, everybody.
Okay, don't forget the code is SendQT. We'll see everybody next week. This has been an Adafruit production. Thanks so much for joining us. We'll see you next week.
Have a great night.
Here is your moment of Zener.